Hi everyone. I want to look at some guided notes from your packet here that talk about how to find the area under the standard normal curve, and then use this sheet as a lead-in to what I'll call application problems, where we're actually going to put all these things to use and find some probabilities in real-world kind of problems. Okay, so to start off, it says here, find the area under the normal curve for each of the following, draw a picture. Okay, so just to review, if I have a z of 0 to a z of 1.56, okay, so I have my bell-shaped curve. I'm going to go here from 0, 1.56 deviations to the right, and I want this area in between. Okay, so at this point, we know how to do normal CDF. And we would tell it 0, 1.56. And if we type that in your calculator, you should come up with 0.4406 as the answer to our problem. Okay, so that would be our area under the curve. And remember, always with normal CDF, we always do the low value and the high, or you can think of it as left to right. All right, maybe one to be a little more interesting is one on down here where it says to the left of 1.21. Okay, so we have a picture here real quick, bell-shaped curve. We're at 1.21 and it says to the left, so I want to shade all the way past the mean to negative infinity. Okay, so in order to do normal CDF, we have to use negative infinity to be negative 1e99 and then 1.21, and when you enter that, your area is 0.8869. And we also can say that as a percentage. If the problem wants the percentage, you could say 88.69%. Okay, both are representative of the area under the curve. Okay, so now application problems. I'm going to go down here to question 12, and it says the length of human pregnancies from conception to birth varies according to the distribution that is approximately normal, with a mean of 266 days and standard deviation 16 days. What percent of pregnancies last less than 240 days? Okay, so less than 240 days. All right, so step one. We want to write this problem in terms of the random variable x. So we're going to say, all right, x is less than 240 days. Okay. Step two is to convert that to a standard score or to a z-score. So we'll say z is less than, okay, and if you remember z, x minus x bar over s. So we'll do 240 minus the mean of 266 all over the deviation, which is 16, and we want that to be rounded to 2 decimal places for z. So I have z less than negative 1.63. So step 3 is to use your calculator with normal CDF. We're going to go from negative infinity, so negative 1e99 comma negative 1.63. Type that in the calculator and you should get an answer of 0.0516. And it says what percent? So we want to say 5.16% of pregnancies last less than 240 days. Okay. All right, second example in here. Actually, in fact, let's go down here to the next question, down here to number 13. Okay, so it says each month an American household generates an average of 28 pounds of newspaper for garbage or recycling. Assume the standard deviation is 2 pounds. If a household is selected at random, find the probability of it generating, in the first part here, part A, between 27 and 31 pounds. Okay, all right, so first step again is to write the problem in terms of x. So we'll say 27 is less than x is less than 31. Okay, because of the between, we've got the random variable there between. Second step is convert each side of this to a z-score. All right, so we're going to do 27 minus the average or the mean in this question is 28 divided by the standard deviation of 2. The other side, converting as well, 31 minus 28 divided by 2. All right, so we're looking at a negative 1.63 is less than z, less than 0.25. All right, so in thinking of your bell-shaped curve, we're over here at 0.25, and we're over here at negative 1.63. We want the area between. So that will be your friend normal CDF. Negative 1.63, comma 0.25. And when you type that in, looks like we're going to land at 0.5472. And that would be your probability. Okay, you can also write it as a percentage, and that's okay too. 54.72%, and that's an okay answer as well. Okay, so that's sort of an intro to application kind of problems. I'm going to stop this video here now, and then you can join me again in part 2, and we'll figure out how to do a little different type of question. If I give you the percent or the probability, how do you come backwards to an original score? That'll be featured in the next video. Have a great day.